Alrighty, hello there. So this is going to be a long video, but I want you to skip ahead to where we left off in class, and so or you can watch the whole thing again if you want. I would watch it in pieces though, because like I said, it might be a little bit long. All right. So like we talked about, all the things that we're about to do in section 12.6 and what you're going to do for your project is on cylinders and quadric surfaces. So not quadratic, but quadric. So it all ties back to things that you did with conic sections back in maybe pre-calculus or algebra 2 or wherever you did that. All right. So you have some basic equations in this orange little area here. And so you got circles, ellipses, hyperbolas. So notice that with hyperbolas, you could also have, these two could be switched right here. So depending on which letter is in front, that's going to be the axis. Like this is the x-axis and the y-axis. And notice that the y value is in front right here. That's why it's crossing the y-axis right there. And then this one over here, notice that y is being squared. That's why the parabola is on its side like that. And of course, we also know that the one that we're used to is y equals x squared, where x is squared. And down here with the ellipses, just notice that basically it has addition, so it doesn't matter if x or y is in front, but whichever is longer here, that's going to be the length, where it's going to be longer that way than this way. These numbers were the length in the direction of whatever letter was above them. Like b squared, b would be the length that you go this way, or actually from here to here. And then over here, this has a squared. A would be the length from here to here. And we don't need to know any particulars, but just in general, that's how the shapes work. And we all know how circles work and everything. All right, so when you do these things, in all these pictures, you had your center was HK, all right, and variables were squared. So in all these problems, except for the last one, both variables were squared. These are going to be some things to look at. So when both things are squared, you get like a closed shape, right? Or you get like basically a closed shape turned away from each other. If only one of them is squared, only x squared or y is squared, then a lot of times you only have part of a shape, like that's like your parabola up here. So that's only getting like half of a picture in a way, all right? And then notice that some of them have pluses or minuses, and plus is like circular things like circles or ellipses, minus is hyperbolas. So there are just some things to notice that you're going to also notice in the surfaces that we talk about here. All right, so here's the big page of everything that you basically need to know. So this part at the top with those red and blue pictures, it was just showing you how those different conic sections were created. But down here, this is what we're going to be looking at. So I want you to notice some things about these pictures. You have what are called traces in these shapes, and those traces are basically kind of like these little black lines on here. So notice like these little trace curves right here. Those, ellipsoid, its traces are ellipses, right? And so then, for instance, this elliptic paraboloid, you see these little black lines are parabolas. So its traces are parabolas. This one over here, the hyperbolic paraboloid, I said that kind of weird, hyperbolic paraboloid. And so it has a bunch of, hyperbolas. So notice like the hyperbolas here, and this one is a crazy shape. None of you got that for your shape to do because that one's too creepy. All right, and then you have your cone and all the others, hyperboloid of one sheet, hyperboloid of two sheets. Cylinder, you pretty much already know, and parabolic cylinder, you kind of know that a little bit. We've done that some. All right, so we're going to start off with some of these easier ones that you know a little bit and see how to draw them. So you've already learned two special types of first surfaces, planes and spheres. And frankly, we've already done cylinders as well. So what we're going to learn how to do is learn how to draw these, because you're not always going to have like something there to graph it for you necessarily. I mean, I guess with virtual school, like you might actually have that. But anyway, you're going to learn it with traces, okay? So in order to sketch a graph of a surface, we just think of what it looks like when the surface intersects a plane parallel to the x, y, y, z, or xz planes, all right? And so remember that the xy plane, that's when z equals 0. So I'm going to draw on here a little bit, but don't draw it yourself. So if z equals 0, so remember you have a plane involving these two lines right there. And yz plane, that's when x equals 0. So that means you have the plane that goes through these two axes, the z and the y. So it's like this flat surface, like facing you that way. And then when you have xz, that is like having y equals 0. So it's the plane that involves these two right here. So it's like the plane going sideways in a way. Okay, so I'm going to erase that because I was just using those just to help you out. All right, so when I talk about traces, basically when I say draw something using traces, we're just going to let each of these three things occur and then see what our shape looks like, which one of those conic sections we have left over. All right, so you have x squared plus y squared equals 1. All right, so let's see. So this one, we don't really need, what's it called? We don't really need traces for these kind of simple ones down here because we kind of already know what they look like. But x squared plus y squared equals 1. If I was in 2 dimensions, then I would have a circle with radius 1. So I know I have a circle with radius 1 if it was flat. And then it's, z is, doesn't get told what z is, so z can be anything. So that's why we have a cylinder like going up and down along the z-axis, parallel to the z-axis. And it's just the outside of that cylinder, so it's hollow. All right, so it's just a cylinder right there. So you want to describe it a little bit, cylinder parallel to z-axis. And actually it's on the z-axis. Radius is 1 here, and we want to mention that it's hollow to describe it in case our picture really stinks. It goes up and up, up and down forever. All right, z equals x squared. So I always like to think back to, like, let's say like in 2 dimensions when I have y equals x squared. So that would be a parabola that hugs the y-axis and goes out along the x-axis. Okay, so that would be basically if I rearrange those letters, I would have z equals x squared. So it's going to be going out along the x-axis still, but it's going to be hugging the z-axis. So that one is just my basic parabola coming up here, and it's kind of hard to like turn it. I can't turn it the right way for you, but it goes all along the y-axis. So basically it travels out this way and that way the whole way. So excuse my 3D drawing right here, but if I could, I would kind of make that curvy, and then this part is like behind. All right, and it keeps going this way. Right? Oh gosh, I kind of stink at this in regular drawing, and so in 3D, I mean with this Apple pen, it's even worse. All right, but anyway, it's like a taco or like a folded up napkin or something like that, going along the y-axis there, like in a parabola shape the whole way. Okay, so this one is actually called, this one back here, cylinder. This is a parabolic cylinder. So it's almost like a cylinder that got sliced and kind of opened up. Like think of a soda can. If you slice the top of it and didn't have the ends, but if you slice the top of it and unfolded it a little bit, then that's what this would be. Okay, so you could describe it. You could say it's parallel to the y-axis, and yeah, because the y value is missing there. All right, and this last one right here, letter C. So this is, again, is it just another cylinder. It's going along the x-axis this time, and the radius is 3. So let's see, x-axis going with radius 3. So we'll just try and draw it. It's touching 1, 2, 3 here, 1, 2, 3 there, up 3, down 3. So that'd be about the best I can do with that. And then it just keeps going along there. All right, so cylinder parallel to the x-axis, in this case along the x-axis, radius of 3, and it's hollow. All right, so again, we've already done some of those. Okay. All right. So here we go with the fancier ones to see how to draw these and to know what they are. All right. So quadric surfaces are the 3D counterparts of conic sections. These equations are always going to contain all three variables. So you notice the last ones, they only had two variables, right? And they weren't all squared necessarily and so forth, okay? They take on two standard formats. It's either going to be ax squared plus by squared plus cz squared equals, I'm sorry, not equals, plus j equals 0. So notice that all three parts are squared right there. All three letters are squared. You have A, B, and C in front of that, and they're all there. But some of these could be negative. You know, A, B, or C could be negative. So it's not that everything's positive, but everything is squared, and you have a constant as well. And then you can also have this form, ax squared plus by squared plus cz equals 0. So in this case, one of them is not squared. And again, there could be some negatives and things like that, but you know, these are just the different formats that it takes on. Okay. All right. So we're going to use traces to try and draw these things. So by traces, I mean to let one of the letters equal 0, and let's kind of see what we have. All right. So let's see right here. If x equals 0. If x were to equal 0, then that means that this part would be gone. So imagine what's left right here. This looks like an ellipse. I have an ellipse along the y and the z axis. So I'm going to say if x was 0, I would have an ellipse. And it would be longer in the y direction. So let's see, y and z ellipse, it would be longer in the y direction. It would go about 3 in the y direction and 2 in the x or the z direction. Okay, so I have that ellipse right there. And then if I have, so that would be like the trace, the YZ trace. If, what's it called? Let's do y equals 0. If y were equal to 0, so basically we're trying to say if this is gone, I would get another ellipse. I would get x squared plus z squared over 4 equals 1. And so I would have an ellipse that goes 1 in the x direction and 3 in the y direction. So I already have 3, so it goes out to 1 right here. All right. So basically what that's doing for me, and I can already kind of tell, I have this shape. It's going around like this, and then it's like that wide. All right. So I know that's super ugly, but I'm just kind of go like this to cover that up. So it's like a football. It's an ellipse, ellipsoid. All right, and so let's just do y equals 0, so another ellipse. Let's finish this off, then I'll show you a better picture of this. If z equals 0, then I also have an ellipse. All right, so I'll show you another picture of that. Where did that thing go? There it is. Oh no, where's my file? Oh darn it, give me a second, I have to find it. I closed it and then it messed up. All right, hang on a second, I emailed it to myself. So let me see if that'll open that up. All right, there it is, good. All right, so there's my ellipse. So that's what I have these kind of like ready for us. So notice it's touching 1, it's touching 3. So that's a little bit better picture. So this is pretty skinny. It looks like a pill or something like that. Okay. All right. So next I have this one. Now notice in the last one, everything was positive. All three things were squared. We had equal to 1 on the other side. So it kind of reminds you of an ellipse equation. All right, this next one. So let's do our traces. If I have x equals 0, so that would be me imagining that this is gone right here. I would get a parabola. And same thing would happen if y was equal to 0. So I'm not too concerned about I just want the general shape. I don't want any specific points necessarily. So I got a parabola. Same thing as if y equals 0. parabola. And if z were equal to 0, that means that this part would equal 0, and that means that x and y would have to be 0 also. So because none of them are negative because they're squared, so I don't have to worry about that part right here. Okay, so if I have the parabola z equals 4x squared, that's a pretty skinny parabola. So along the z in the x plane right there, it's going to be like a skinny parabola. And then it's going to be a little bit wider because then it's z equals y squared. So it's a little bit wider going this direction. But anyway, I have like a elliptic paraboloid. Did I spell that right? Elliptic. Where is it? Oh, 2 L's. I thought it was 2 L's and then I didn't put that. So elliptic paraboloid. All right, so let's go take a look at that one. All right, so in that one right there, there it is. And so notice how it's longer. Remember the green axis is the y-axis, and it's shorter in the, it's more skinny in the x direction, and it's wider in the y direction. So if you look at that. I think this app is pretty cool. Oh, look at that, it's spinning, how cute. All right, so let's do the next one. So in that last one, notice that there was 2 squares and then one of them was not squared, and there was no constant in that last one either. Now this next one, I have 3 things squared, I have no constant, and let's see, if I brought the y over, it would be negative. So notice that the y is kind of like the oddball in a way. All right, so let's let x equal 0. If I had x equals 0, then this one's a little bit different. I would have z squared over 8 equals 2y squared. So I'd have z squared equals 16y squared basically. So if you square root both sides to kind of solve that, you would get z equals plus or minus 4y. So that's a line right there. So that's kind of weird, a line with the z and the y-axis. All right, so I'm going to wait to draw this and you'll see why. If I let, let's see, z equals 0, so if I let x equals 0, I ran out of space, I'm going to get something similar, x squared over 2 equals 2y squared. So again, get x squared equals 4y squared, so x equals plus or minus 2y. So it's another line shape, but it doesn't have as steep of a slope. And then if I try to let, oh, x equals 0, that was z equals 0. Sorry, I made a mistake. I mean, I just wrote it wrong. That was z equals 0. All right, so the last one is if y equals 0, well, y doesn't ever equal 0. So y equals 0, I mean, if y was equal to 0, then everything else would equal 0 also, because when you square stuff and add it up, you can't be negative, and so I don't have to worry about that, okay? So what I have here are lines with the z and the y axis, plus or negative lines, and I have lines with the x and the y axis. All right, so I'm going to try to draw this, but it's going to be really bad. All right, so I have lines with the z and the y axis, so that's these. I'm going to say come in there and come in there because I have positive and negative of the same thing. And then I have lines with the x and y axes. So like coming here and going there. So you're gonna, yeah, I know. So you're gonna see that what's happening here is I have a cone. So let me show you and then we'll draw it. So what I have there, oopsie, okay, stop rotating. I have this cone shape. And if you're able to see it, you see those lines right there, and they're coming up and down, and then they're going side to side. All right, so if I go like this, do you see how those lines are crisscrossing? All right, and then same thing happens if I go like this, those lines are crisscrossing, and so that's what you're seeing right there. Okay, so it looks horrible when you try to draw it by hand, but you kind of have to know that you have a cone. And I know cone in your mind kind of implies one thing, but it's really 2 sides to it. Oops, wrong app. Oh, okay, so we're just going to kind of draw it like that. And notice that y is the odd man out. It is by itself. So this is a cone along the y-axis, or parallel to the y-axis, because he's the one over here all by himself. All right, so make sure you take a little break. The video is getting a little bit long for you, but you know, maybe you're not watching all of it at once. All right, this next one, z equals y squared minus x squared. All right, so this is going to be a tough one. It's going to be a little bit creepy and weird, but just stick with me here. So I'm going to let's say, x equals 0. I'm going to do x equals 0, y equals 0, and z equals 0. Okay, so if x equals 0, I would get z equals y squared. I get a parabola shape with y and the z-axis. So it's kind of like x equals y squared, but you see I'm going to have a parabola shape with z and y. Let's see. So it'd be kind of like this. Okay, so it's like that right there. Okay, so just remember that idea. All right, if y equals 0, I would have z equals negative x squared. So z equals negative x squared is going to be a parabola, but it's upside down. So it's going to be like this, if you can imagine it going along the bottom of the z-axis. Okay, all right, now the last one, it says if z equals 0, then I would get 0 equals y squared minus x squared. So I'd get y squared equals x squared. So I'd have y equals plus or minus x. So that's kind of like lines, so kind of like that cone thing that we were talking about before. So let me go show you what this looks like, and let me then show you why. All right, so here it is. So this is the worst one. This is called a hyperbolic paraboloid, and we're going to call this a saddle. So if you imagine if this was like a saddle on a horse, so you see how it looks like a saddle, hopefully. You know, here you are sitting right in the middle with your legs on either side, and hopefully, do you see that that parabola, those parabola shapes there being created with the y and the z-axis, and then you see this parabola facing down like I showed you with the x-axis and the z-axis. All right, so this is called a hyperbolic paraboloid, a saddle, and it's going to be really horrible to draw, but we're just going to try our best. Okay. All right, so again, don't fault me for drawing this horribly, but I'm going to, let's see, I'm going to draw it here, and then this kind of comes around, this comes down. All right, just wait a second. This one comes out, comes down, and let's see, I'm going to draw this going back. This one is back here, connecting that. So that's going to be our saddle. And again, if you want to try and draw it better, you feel free. But that's why we have that other picture to kind of help us out as well. Okay? All right. So again, the saddle. And so that's going to be like our nickname for it. It's a hyperbolic paraboloid. Because, you know, it's kind of like you have it's like a hyperbola and a parabolas together, like mushed together. All right. All right. So this guy. So notice like something weird, fishy is going on here. We have one of the variables negative. They're all squared. It's equal to 1. So I'm going to get some kind of parabolas and ellipses going on right here. So let's do our thing. X equals 0, y equals 0. These are our traces, and z equals 0. Okay, so if x were equal to 0, so I just want the general shape. If x were equal to 0, this would be gone. So I would have a hyperbola touching the y-axis. And the z, it's going to hitting the y-axis at 1. Okay, so I'm just going to draw. So that would be y squared minus z squared over 4 equals 1. So touching the y-axis at 1, I'm just going to draw like some parabola shapes over here. Oh, let me fix that one. some parabola shapes or hyperbola shapes over here. All right, so stick with me for a minute. If y was equal to 0, then I would have x squared over 4 minus z squared over 4 equals 1. So that would be another hyperbola touching the x-axis at 2. So it's kind of going like this and like this. Okay. Then if z equals 0, well, if z equals 0, I have x squared over 4 plus y squared equals 1. That's an ellipse. An ellipse that is going along the xy plane. And it has, it goes 2 in the x direction and 1 in the y direction. So, let's see, xy. Sorry, I'm just thinking for a second. All right, well, let me finish draw this and then I can show you this on the next page. So this is going to be what is called a hyperboloid of one sheet. So it's going to be like this, and I know that's ugly, but I'll show you. It kind of looks like this if I drew it better, like that, and it like comes across like this, kind of skinny in the middle. All right, and so let me show you the other parts that I was talking about. All right, so here we go. So remember, oh, wait a minute, xy, I must have done something mixed up there. Let me go back. I'll go back and fix it in a second. But anyway, notice that z is the one that was by itself, so it's going along the z-axis. That's my mistake that I made right there. Notice those hyperbolas along its sides, and also notice that ellipse right there. Look, it goes out to 2 on the x-axis and 1 on the y-axis. Okay. So I made a mistake with my thinking about one of these things. So let me erase that picture and we will get it all fixed up. Sorry about that. All right, so let's start up here again. So y and z in the first one. So the y and the z-axis. Oh, I see. All right, so it touches the y-axis at 1. And those hyperbolas, oh, okay, I'm sorry. So those hyperbolas are going to be like more like this. And I drew them, so they're facing up and down, not like flat. I drew them on the xy plane before, my bad. All right, and then y equals 0, I'm going to have x and z. So those parabolas are coming across at 2, so they're coming across like right there and then back here. So that's creating like your little your cylinder in a way in the middle, even though it's not a cylinder. And then the ellipse is going on the xz plane, so that's like your centerpiece right here, going 2 in the x direction and 1 in the y direction. So that's your shape. I know that looks super horrible, but basically that's what's going on here, and then the sides are coming in like I showed you before. All right, so it's going up and down the z-axis, so it is along the z-axis, right? And it is a hyperboloid of one sheet. It's hollow, and if you look at sometimes like nuclear power plants, there are some pictures of some online, and they are like kind of this shape in a way, and so that's kind of cool. Anyway. So there we go. That's a little bit better picture so you can see everything going on right there. So my mistake is I drew my hyperbolas flat and they were supposed to be up and down like you see here. And there's your ellipse right there. All right, so let's take a look at the next one. All right, we're almost done here. So sketch this surface. So notice here that there's 2 negatives and 1 positive, so that's something a little bit different. So the oddball here is the y value. So basically the oddball is going to be important because that's usually going to tell you what axis this thing kind of follows. All right, so let's do our thing. X equals 0, y equals 0, z equals 0. All right, so if x were equal to 0, so that means that this guy is gone. I have a hyperbola and touching the y-axis, okay, at 2. All right, so I would have y squared over 4 minus z squared over 2 equals 1. So hyperbola touching the y-axis at 2 and kind of going up and down. Okay, all right, because it's on the y and the z-axis. If y equals 0. All right, so if y equals 0, look at what would happen. If y were equal to 0, you would get negative x squared minus z squared over 2 equals 1. Well, that's never going to happen because you have two negative things adding up to 1, not going to happen. So you know what? Y can never be 0. This is never going to happen. So that means the y can never be 0, so you're never going to be inside here. You're never going to touch the origin right there. Okay? And z equals 0. If z were equal to 0, then you would get negative x squared plus y squared over 4 equals 1. So again, that would be a hyperbola along the touching the y-axis at 2. We kind of already have that. But basically, that's going to be with the y and the x-axis, so it's going to be a hyperbola coming this direction. And it's going to be coming in that direction. So what you get these little like cup or kind of bowl features on either side. So let me show you on the other one. Ay, whoops. So do you see that? And so you look at it this way, you're like, oh, it's a hyperbola. You look at it that way, you're like, oh, it's a hyperbola on the x and the y axes. Oh, it's a hyperbola on the y and the z axes. All right, so you see them from those things, and these little like bowl kind of shape things. Okay, alrighty. So again, our picture, so you want to say that this is a hyperboloid of 2 sheets. Because basically it was like the other one, but it got squished so much in the middle that it got like cut off and broken into 2 bowls. So it's kind of like this one in a way, but it got so skinny in the middle that it squished off and broke into 2 bowls in a way. All right, and yeah. And so also, if it helps you too, you can do some drawings. You can say to yourself, oh, this is the x and the y-axis. It touches the y-axis at 2 like that. And up here, you draw the, the z and the y-axis, and it touches the y-axis at 2. So you can do some little side drawings so that you can kind of picture it as well, unless you're a good artist. All right, and look at that, we're the last one. Whoopee! You think you're tired of watching. I'm tired of making this video. All right, so here we go. Now this one is kind of messed up. We have to fix this up first. We're going to fix the format. So notice that I have this x is separate from this other x right here. I'm going to put those together. So I'm going to have to complete the square. So I got x squared minus 6x. I'm going to leave a space to complete the square, plus 2z squared. And that's not going to do anything. Minus y plus 10 equals 0. So I'm just going to complete the square on the x part. So I'm going to take half of 6, which is 3. 3 squared is 9. So I'm going to add 9 here. And I'm basically going to just take 9 away since everything's on the same side. So I have x minus 3 squared plus 2z squared. And let's put everything else on the other side. Y is kind of the oddball here because he's not squared. So that's going to tell us something. And I got y, and that would be a 1 there, but it's going to be a minus 1 right here. All right. So let's do a little bit of vertex work here. So if I was thinking about a vertex here, if I want to make everything bottom out to 0, I would have to make x be 3, z would be 0, and y would be 1. And then I would get these two sides equal to 0 on both sides. So that point's going to be important. Let's go to 3, 1, 0, like right there about. And I know it looks like it's below, but I tried to stay on the xy plane. So 3, 1, 0. All right, so let's do our traces. X equals 0, y equals 0, and we'll do down here z equals 0. All right, so if x were equal to 0, what would happen here? If x were equal to 0, I would get 9. I would bring that over. But either way, I would have some sort of parabola because I would have like y equals 2z, I'd have y equals a z squared. So this is going to produce a parabola shape. And I'm just going to put like y equals z squared. So a parabola shape hugging the y-axis and along the z-axis. So it's going to be up this direction, up and down. Okay, all right. And notice it's along the positive y-axis, all right, because it's not y equals negative z squared. That would be over here somewhere. Okay, all right. So next one, y equals 0. If y were equal to 0, that's a problem. If y were equal to 0, then I would get two squared things adding up to -1, which is not going to happen. So good, less work for me. All right, if z were equal to 0, I would get x minus 3 squared equals y minus 1. I would get a parabola like y equals x squared. So I know that there's more to it, but it's y equals x squared basically. So a parabola along with the y and the z-axis, so a parabola coming off like that. So this creates a little bowl. Okay, so this is called an elliptic paraboloid. Okay, so it's like a bowl or a cup. Now notice what happens here. It was facing in the y direction because if you look at it, he was the only one that wasn't squared. I had x and z squared right there. So let's take a look at that picture in our app here. Oh, please work. Darn it. I'm sorry. I don't know why it keeps doing this. All right, here we go. So here's that thing right there. So notice that point right there. There's my 3, 1, 0. Notice I have a parabola on the xz plane. And if I show you the yz plane right there, there's another parabola that we were talking about. So pretty nifty. All right, so don't worry about these problems down here. We'll talk about those in class. Also, don't worry about this. We're going to do this in class where we're going to try and like kind of summarize things and kind of like a little cheat sheet in a way. Also, do not worry about this. I might have you do that in class. I don't know. It's just going to be like a little practice to recognize the shapes and kind of tell what's going on with them. All right, so